Hello and welcome. In this lesson, we will develop a sample application using random and switch case commands to reinforce these topics. In the example, we will examine each time the button is pressed, a random LED connected to pins 3 to 6 will be selected and turned on, making it unpredictable which one will light up. The goal is to demonstrate how random selection works. It can be used for simple games, decision-making, or just as an interesting visual effect. We have previously discussed the connection of LEDs with resistors and the wiring of the button. The long leg of each LED is connected to the digital pins through a resistor, while the short leg is connected to the ground line. As for the button, one leg is connected to the voltage line, and the other leg is connected to both the digital pin and the ground line. After covering these important details, we can now examine the necessary code for the circuit to function properly. First, we define a variable of type integer named button. This variable will be responsible for checking whether the button has been pressed or not. Since we have connected the button's output to digital pin 2, we set the value of this variable to 2 accordingly. Next, we define another integer variable named green. Since the green LED is connected to digital pin 3, we assign it the value 3. Similarly, we define the yellow LED with a value of 4, the blue LED with a value of 5, and the red LED with a value of 6. These numbers correspond to the digital input or output pins on the Arduino board where each LED is connected. Then, we define another integer variable called number. This variable is used to store the randomly generated number. Initially, we set the value of this variable to 0. In the setup section, we use the pinMode command to define the input and output connections. When a digital pin is used to receive data from an external source, such as a button press, it should be set as input. So, since the button will send a signal to pin number 2, we define this pin as an input using the pinMode command. If a digital pin is used to send data outwards, such as turning on an LED, it should be set as output. So we set the green, yellow, blue, and red LEDs as outputs, since we will be sending electrical signals to these pins to turn the LEDs on and off. By using randomSeed, we ensure that each time the program runs, a different sequence of random numbers is generated. This prevents the same numbers from being produced in every run, making the randomization process more effective. Now, we move on to the loop section, where the main operations take place. First, inside the if condition, we read the state of the button variable, which represents digital pin 2, using the digital read command. If the button is pressed, the pin state will become high. If the button is not pressed, it will remain low. If the button is pressed, then we generate a random number. The random 3 to 7 function generates a random number in the range of 3 to 6 because the upper limit 7 is not included. This ensures that the number is always either 3, 4, 5, or 6. Now, we use the switch case structure to determine which LED should be turned on based on the randomly generated number. The switch statement checks the value of the number variable and executes the corresponding case. Each case represents one possible value that the number variable can have. If the random number is 3, then the green LED should turn on, while all other LEDs should remain off. If the random number is 4, then the yellow LED should turn on, while the rest should be off. Similarly, for 5, the blue LED will turn on, and for 6, the red LED will turn on, with all others off. Each case block follows this pattern. The digital write green high command sends power to the green LED, turning it on. The other LEDs are turned off by setting each of them to low, using the digital write command. The break statement ensures that once a case is executed, the program exits the switch case block without checking the remaining cases. The program proceeds line by line after the switch structure. If a matching condition is found, there is no need to check the remaining conditions, so we include break at the end of each case block. The same logic applies to the remaining cases for 4, 5, and 6, each turning on the corresponding LED while turning off the others. Could we achieve the same functionality using an if block instead of switch case? Yes, we could. However, depending on the situation, the switch case structure is often more efficient and readable than using multiple if-else statements, especially when handling multiple conditions. An important note, when defining case statements, make sure to use a colon instead of a semicolon. This is a key detail to remember. At the end of a switch case structure, we can also use default. The default statement is used to specify an action when no other case conditions are met. However, in this example, we do not need a default case because we have ensured that the generated number is always between 3 and 6, meaning there are no unexpected values. After closing the switch case block, we also close the if statement. It is important to note that we used switch case inside an if block. This means that the switch case structure will only execute when the button is pressed. In other words, the operation of switch case depends on the button press. At the end of the if block, we add a delay of 250 milliseconds. This allows us to visibly observe the LEDs turning on and off before the next button press is detected. Finally, we close all brackets for the if, switch case, and loop structures, completing the program. Now, let's run the simulation. When we press the button, we observe that a different LED turns on each time. There is also a possibility that the same LED may light up consecutively if the same number is generated multiple times in a row. Now that we've finished reviewing the code and simulation, let's examine the physical circuit in action. When we press the button, one of the LEDs turns on randomly. Each time we press the button, a different LED might light up, or the same one could turn on again. This happens because the system selects a new value every time the button is pressed. The LEDs do not stay on permanently. Only one LED is active at a time. Once a new selection is made, the previous LED turns off automatically and the newly chosen LED lights up. Due to the delay command's pausing effect, sometimes the button press may not be detected, or it may register as multiple presses in a row. When we hold down the button, we observe that the LEDs continuously change at 250 millisecond intervals. I hope this demonstration helped you understand the logic behind using random numbers and switch case structures in Arduino projects. If you found this video useful, don't forget to like and subscribe. See you in the next lesson.